This video is going to be about solving exponential equations without logarithms, and then later on in the unit we'll have one where we're solving exponential equations with logarithms. And so today in this video, what you need to think about is if I have 2 to the 4th power, which equals 16, but let's say I have it equal to 2 to the x. Essentially, these are exponentials because you have a base raised to an exponent. And the idea here is that today, if you can get the bases the same, right? If the bases are the same, whoops, don't even know what happened there. Right, so if the bases are the same, then you can set the exponents equal to each other. And so, to each other. So obviously the answer to that equation is x equals 4. However, we're going to look at a little bit more difficult problems, but that's basically the idea right here, is that in an exponential equation, if I can get the bases to be the same, then I'll set the exponents equal to each other, and I will be able to find what x equals. So take this one for example. We've got first one, we've got 5 to the 3 minus 2x equals 5 to the negative x. So the first question you ask yourself is, are the bases the same? And the answer is yes. And so I'm going to set the exponents equal to each other. So don't worry about the 5's, right? We're just concerned, when does 3 minus 2x equal negative x? And we have a linear equation, we can just solve it. So plus 2x, and I'll have 3 equals x. So our answer is just going to be x equals 3, and that's it. However, what happens, let's say, like if the bases aren't the same, right? So if I move this up a little bit, and we have, for example, 2 here, let's go with 3 to the 1 minus 2x. Let's say that equals 243. So later on in the unit, we'll talk about how a logarithm could help us out here. However, what we're going to do right now is we're going to try to create the same base. So the thing about this is 243 is the only one that you can change because 3 is a prime number and there's not much you can do to change 3. Now, I'm not going to do anything to both sides. I'm literally just going to rewrite 243 in a different way. So 243 is the same thing as 3 to the 5th power. If you use a calculator, hit pause right now and use a calculator, you can see that 243 is 3 to the 5th. So then I have 3 to the 1 minus 2x, and it equals 3 to the 5th. And so now I've created the same base, and so what I can do is I can set the exponents equal to each other. So 1 minus 2x, and that equals 5. And then we can solve it. So subtract 1, negative 2x equals 4, divide by negative 2, x equals negative 2. And if we want to check our answer, we could. You'd take x, equaling negative 2, and plug it into the original way up here. And so if you put negative 2 in for x, that'd make 4, and so 1 plus 4 is 5, and 3 to the 5th is 243. So your answer is right here, x equals negative 2. Alright, there's probably one more that we should probably look at, maybe 2, I don't know, we'll try and see what happens, but there's 2 situations that, or not 2 situations, but one situation that I think might be interesting using properties of exponents, and probably people like me like these kinds of questions. So 3 to the negative 2x plus 1, and then times 3 to the negative 2x minus 3 equals 3 to the negative x. And then I'll do a different one. I'll create a little divider there. And then another one, let's do 2 to the x times 1 over 32, and then equals 32. So in all of these problems, what I'm going to do is I'm going to create the same base if I don't have it, and if I do have it, then I'm going to work from there. So in the first one, I have 3's everywhere, right? 3, 3, 3. So now I'm being asked to multiply them. What you want to do is you want to multiply them together, and so since we have like bases, we can multiply them together. Remember, you keep the base the same, and then you add the exponents. So I'm just going to add those exponents. That would make negative 4x. And then 1 plus negative 3 would be negative 2. And then that equals 3 to the negative x. Now you have one exponential on each side, and then you can set the exponents equal to each other. Before, you didn't really have an opportunity to set them equal to each other because you didn't know which exponent would equal negative x. So by doing properties of exponents and adding those two things, then you're able to have one exponential on the left and one on the right. So you can say negative 4x minus 2 equals negative x, and we can solve that. So plus 4, plus 4x. So I have negative 2 equals 3x. I divide by 3. I've got x equals off to the side over here. X equals negative 2/3. Then over here with the second one, I like this problem, and I think the reason I like it is because you kind of got to think a little bit about powers of 2, right? So I'm going to try to write everything with a base of 2. So this one's already 2 to the x. If you can think about 32, 32 is 2 to the 5th. So 1 over 32 is 2 to the negative 5th. And that equals 32, which is 2 to the 5th. And now we have the same situation where we started in the last one. So I have like bases. When I'm multiplying them together, right, I add the exponents. So I keep the base the same, 2, and then I do x plus negative 5, which is just x minus 5, and then equals 2 to the 5th. And now I can take x minus 5, set it equal to 5, x is going to equal 10. And there's our answer. Alright, so solving exponential equations, make sure you have the same base. Create that same base by rewriting it. And once you have the same base, you can set the exponents equal to each other. Alright, talk to you later.